Hello, I'm Joshua, and I'm here to dispel a myth about Scribe Online connectors. They're not hard to build, they're very easy, they can be very fast, and you can get them deployed and get to working on your solution very quickly. And that's what Connector Outlaws is all about. It's about building your connector, getting it out there, and doing it quickly and fast. Hello, I'm Joshua Solomon. I work for Scribe Software. I'm a technical evangelist, and I help partners build connectors to work with Scribe Online. And what I want to do today is I want to talk about how to evaluate your API and whether or not that API is going to work well with Scribe Online's Connector Development Kit. So what are connectors? What do connectors do with Scribe Online? Well, connectors expose data to Scribe Online. It exposes your data structure so that your data can be shared with all of the other applications that Scribe Online works with. Connectors are easy to create. Once you create those connectors, that's a one-time effort. Once you create those connectors, you can build solutions to any number of the applications that we support. Building connectors has two options. We have what we call our Connector Development Kit, and we have our FAST framework. These two items we're going to talk about in future episodes. We'll talk about what the difference is and what they bring to the table. Both options are free. We provide the FAST framework and the Connector Development Kit to anyone who asks for it, partners, customers, including trial customers. These connectors that you build with these frameworks can be used with trial Scribe accounts. They can be used with production accounts. And if in the future you decide that you want to go live with a solution that you've created with your connector, we can get those certified and be put in the marketplace. And it doesn't matter which type of framework that you work with. So, deciding what framework you want to work with, deciding what applications you want to expose to Scribe Online for use with solutions, that's what we're here to talk about today. We're talking about how to evaluate your API. And so let's get into this. What is an API? An API exposes data to be used with the rest of the world, with any other application. And there are multiple APIs, or multiple examples, great examples of this. Microsoft Dynamics, an ERP system like SAP, Salesforce, SalesLogix. They all have great APIs that allow you to integrate your applications with other systems. And so what we're going to do is we're going to take a look at a couple of these today, and we're going to start with looking at Salesforce, which we're all familiar with, or most of us are familiar with, and we're going to compare and contrast that with another API for a product called ClubOS. ClubOS allows you to, it's an applicant tracking system for health centers. So the first question we want to ask when we're evaluating an API is this API does this API get treated by its vendor as a product? A lot of folks, their API is an afterthought. We don't work well with APIs that are just afterthoughts, because an afterthought product, an afterthought to your product is really not well maintained. So we want APIs that are distributed as a product. And so what we can do is we can take a look at a couple of examples here, and let's talk about Salesforce. So here what you can see is I've got the Salesforce REST API up on my screen, and we can see that it's well documented, it's proofread, and we can scroll down and we can see any information that we're interested in working with is available through this API. Here's the API on a documentation on how to query something out of Salesforce. So this is treated as a product by the Salesforce organization. They actually put QA into this. This is a very good point for an API evaluation. It's very good to have something that's well documented like this. And we can take a look at some others. Here is ClubOS. Again, it's got its own website. It's very well documented. It's professional. These are the things that we want to look for when looking at an API. A professional API means that they're paying attention to their customers that are integrating with other systems. Okay, so the next thing we want to talk about is open standards. Does your API, the one that you want to share data with Scribe Online, does your API support open standards? What does it support? Is it SOAP? Is it REST? And how do you know this? Is this documented? And so we can look at those two APIs that we just looked at, and we saw that, yes, in fact, they were both REST-based. We can scroll through them. We can see that they have standard formats that they export data in. Here at SalesLogix, we can see that they're using HTTP GETs. The format that you can get data back in is in JSON or XML. It's up to you. That's very good as well. It's flexible. So it's a standard. It's flexible. And those are good things about an API. We're very good on these APIs so far. One thing that not a lot of APIs is becoming more common, but not a lot of APIs in the past exposed metadata. One thing that we're very meticulous about at Scribe Online is metadata. We expose to the user metadata for you to do mappings with. Fields, relationships, tables, all of that information is what we expose in Scribe Online. If you're familiar with Scribe Online, that's how we expose it. And you use that information to drag and drop fields from one API to another. And so one thing that APIs didn't do was they didn't expose metadata. And so what we look for in a good API is the ability to retrieve that metadata programmatically rather than having that metadata dynamically sent to you. So there are some REST APIs that will send you a response, and in that response you'll have all of your fields, including custom fields. Whereas we don't want to send a request in order to get that information. We just want to send a request that says, give me all the tables and fields. We don't want to have to insert something in order to get back a list of fields that we know we're going to work with. So a metadata call, relationship definitions. So these things are important in an application. So here I'm going to take a look at the Salesforce application, the API documentation here, and I'm going to look for some metadata retrieval calls. And so I'm just going to look right down the reference here. And so as I come down here, it's actually the very first item here. We've got SO object basic information. And this actually gives us the object name. So what I do is I can get the object name, I can get all of the metadata for that object, and it says right here in the documentation, I can get all of that metadata, and it actually points me to the routine to actually create data through that object as well. And we also have, just above that even, a describe global, which actually gives a list of all of the objects in the system. So again, this is a very good thing because going forward with creating a connector in Scribe Online, this is one of the very first things that we need. We need metadata in order to expose that in the UI. So again, another good example of an API, and I'm going to move over to ClubOS. And when I look at ClubOS's API, it's a very focused API. You can see every single API call listed here on the left-hand portion of my screen, and we don't see any metadata retrieval methods here. Now, that's not necessarily a bad thing, depending on the use case. In this case, we can see that the API only supports a few basic calls, and with our use case with ClubOS, we only have a few basic things that we want to do with it anyway. So this may be okay that the metadata is not there, depending on how the metadata comes back, on how the fields come back to you when you make a call. And we'll see that and how to deal with that in the future episodes when we talk about the CDK and the simple framework. So this particular API does send back your list of fields. as JSON data. And they actually do describe that data here in the documentation. So we can see that it sends it back in JSON data from a REST call, and we can see what fields come back and what's going to be in those fields. So this isn't necessarily a bad thing that the metadata call isn't there. We just need to understand it going forward, and that helps us to decide how we're going to deal with building a connector in the future. All right. So along with metadata, we like to see relationship definitions. So if you have multiple tables, say in a CRM system like Salesforce, you want to have a key that relates sales orders to sales details, etc., contacts to addresses, etc. So relationship definitions as part of that metadata is important. The next thing we want to know is an application or an API change aware? Now, change aware is very important because what we don't want to do is we don't want to have to go back to an application and always get the entire data set and process through it. What we'd like to be able to do is the first time through, maybe we get the entire data set and process through it. But going forward, after we've got our solution in place, we only want to deal with the changed data. That way we're not running as many records through the process. So is the API change aware? And how do we know that? And if it's not change aware, what can we do about it? Can we filter on certain fields? So what makes an API change aware? We'll go back to Salesforce and we'll take a look. Really, what's happening in Salesforce, and we all probably already know the answer, is when we look at an entity, we want to know if that entity has things like fields like modified on, modified by, etc. So that's what we're going to look for when we look through a list of objects or a list of views. And very quickly, we can go through the Salesforce application, and we can determine whether or not they have modified dates, etc. If I come over into ClubOS, again, I can very quickly determine whether or not that's the case. So I'm going to go on to the basic item, which is a user profile for a fitness club user. And I can scroll down through this list. And when I scroll down through this list, what I can see is a created date, but I don't see a modified by date. So this one's kind of a iffy situation. We can filter by the user ID and we can filter by created date, but we can't really go back to this user and filter by any new activities that have taken place since the last time I looked at it. So again, depending on the use case and how this integration is going to be used, that could or could be or could not be good. So we'll move on. Another item, unified operations and batch versus real-time items. So unified operations. Unified operations allow us to reduce the number of calls that we make to an API. For instance, if I need to take new information from System A and put it into System B, I can take that information, and the typical flow is that I'm going to look up into System B to see if that information already exists. And if it does, then I want to update that information. But if it doesn't, I want to insert that information. And that is, in effect, 3 separate calls: a lookup, an update, or a create. And that can get expensive to do that lookup every time. So what we look for in APIs is whether or not they have multiple operations, such as an upsert. And Salesforce is a great example of a system that does have an upsert, and our ClubOS actually does not. It simply has creates and modifies. So in that case, we do have to do the long way. We do lookups, creates, or updates. Whereas with Salesforce, we can do a single call and forget about it. It's a fire and forget, and Salesforce will take care of doing the other end of that processing. Salesforce will put it into the correct place when it needs to. So we save processing time on our side because the API has these multiple operations, these unified entities and unified operations. That's one item. Unified entities and operations can also refer to whether or not multiple entities can be accessed in the exact same manner. And to give you an example, we'll go back to the Salesforce application and we'll take a look at a query. And here, what we can see in the documentation is that they have one documentation page for query. That means that you can use this one query operation to query anything in the Salesforce system. You write the query, you pass in the object that you want to query, and you pass in the filter that you want to query. Whereas less sophisticated APIs, less productized APIs, will have a separate method call for every single object in their system. So you'd have to query contacts, query accounts, query addresses, as opposed to just a query where within the query you put your filters. So that's another term for unified operations and entities. Batch versus real-time. Another efficiency item, not necessary when dealing with a connector, but depending on the volume of data that you're going to deal with. If you're going to be dealing with hundreds of thousands of records on a daily basis, you probably want to find a way to batch upload those things, because what that does is that reduces operation time on your end, both with your application and its data server, and it can reduce the API calls for the application that you're inserting into. So Salesforce, again, does have batch operations, and that reduces the number of API hits you send data to Salesforce. I can send data 100,000 records in a single batch, as opposed to 100,000 batches, which I will get charged by Salesforce. There is an API hit limit. And that also works with Scribe Online. Scribe Online does track the amount of data that goes through your system. So, filters, queries, and paging. We've talked a little bit about all of this in the past, or so far. We haven't really talked about paging, but what we want to talk about, what we want out of filtering is we want to see an API that allows you to filter by multiple fields. It's good to understand what you can filter by in an API, and so when we go and we look at an API such as ClubOS, we can take a look at each of their items. So let's look at their prospect services, and we'll look at prospects here. And we can see that the input parameters include club location ID and user ID. So the input parameters that get me data back, or even the post parameters, the input parameters are limited to the IDs. So we can't really search and filter based on created date or home address or anything like that. And so that's kind of a limitation to filtering in this particular API. Whereas we know with Force.com, we can filter by pretty much anything within an entity. So it's good to understand what you can and can't filter by. Along with that goes the querying. How generic is the querying? Can you query any entity? Are there limits to what you can query? And are there limits to how much you can query? Does the API send you back large data sets? And if it does send you back large data sets, does it send it back in pages? Does it expect you to send pages of data to it, or does it send everything back all in one large chunk? So it's good to understand all of that to while you're evaluating the API, and whether or not that API is going to work well with you when you go to create a connector using Scribe Online's connector development kit and the simple framework. And last thing, I did mention this briefly, it's combination operations, upserts versus upsert and insert, and multi-threading. Does the API support multi-threading? Can you send multiple requests to it simultaneously in order to process large data sets faster? So it's important to look through your API documentation, look through the API of the application that you want to connect to Scribe Online, whether it's your own internal application or it's a third-party application that you're working with, and understand these points and take that in when you're getting ready to build a connector with Scribe Online.